We're going to talk about industrial illumination beyond 2020. So, in order to understand industrial illumination beyond 2020, we should really understand where we come from. And I tried to find a lot of information on evolution of lighting, like before I was born, and stuff that I haven't witnessed. But when you search for evolution of light, you really come up with this. I guess most people are not interested in evolution of light as much as I am, or different kind of light. So what I was looking is for something more like this. And actually, the changes are there quite incredible on their own. So for centuries and centuries, where light was considered open fire of various sorts, then the electric lamp came in. I'm not going to go into details because we've got a lot to cover. And fluorescent lamp, and now we're onto the LED. There's different technologies that are emerging as well, and they're also quite interesting. That's what we're going to look at today. And it's actually now becoming a revolution of light. So, in order to understand like, where we're trying to be in the future, let's have a look at what actually makes an ideal perfect light, or perfect light source, I guess. So if I was to consider an ideal light, if I was to travel into the future and find me the best light source possible, then I would be looking for something that can illuminate a very large area, because that's what we're trying to do. You want to minimize glare and lighting pollution, because if you're the observer of the light, if you're in the audience, for example, or on stage, you don't want to be glared by the light. So you want to have a lot of light around you, but at the same time not glared by it. Kind of goes against the physics a little bit, and that's where it gets really cool. You want to use the least amount of energy. You're going to want a light that has all of that and doesn't consume that much power. That would be fantastic, wouldn't it? She had some office people coming up and going, I've got an idea for you. Let's make light that doesn't consume power. Wow. Sure. Last longer and reduce maintenance. Obviously, you want a light source that doesn't need to be changed. And that's where typically a pain point on many of the mine sites, they don't want to be changing light bulbs. You want a light that runs cool and operates safely. For years and years and years, there were lights that were high voltage, incredibly high voltage, HIDs 1,000, a couple of thousand volts. That's not easy to change. So you need specialized people to go and change it. So you really don't want to. You want to try to get something that's low voltage, and you want to try to get something that's runs really cool, so you don't burn yourself on it. Dirt doesn't stick to it. It's something that's compact and lightweight. Obviously, the lighter the better, and smaller the better. Environmentally friendly, that's a particularly interesting topic lately, particularly attractive topic for everyone. And you want something that's affordable and readily available. And obviously the new technology that comes on is usually not very affordable and usually not very readily available. So we're going to be talking about technologies that are coming up, and obviously they're not going to be affordable now, but 10 years from now, or 5 years from now, that will be a different case. One of the biggest drivers today is the energy efficiency. This is where ever since, we all know it, in the last decade, basically the world switched to drive towards the environmentally friendly. And it's fantastic, and that's actually predominantly what's fueling a lot of the development as well. One of the reasons why LED or lighting field is moving so fast, it's interesting, I mentioned LED and then I mentioned lighting. What I meant to say is lighting, but lighting has become the LED in the last 10 years, in the last 5 years. So one of the reasons it's developing so fast is because it is one of the most environmentally friendly light sources, that's speaking bluntly, out of everything that we have, but there's new stuff coming up. So when we're talking about energy efficiency, really one of the best, if we can talk fluff, or we can actually look at the numbers. The physics behind it is light source produces lumens of light, and light is emitted in lumens, and how many of lumens of light do we get per watt of power that we consume. And since we're talking about history, this is kind of the lumens per watt history. This is pretty much the graph that I was originally looking for. This is showing you the evolution of light from in time against the efficiency of how efficient it is at producing light. So you'll see the incandescent light source, that the original Edison lamp, has been going before everything else started, and then some gas discharge lamps appeared in the 40s. They really took off in the 60s. That's why they split into different technologies, and that's actually the light sources that we have still today. So this is what majority of street lamps are. This is the majority of all the lighting on your side is. Fluorescent lamps is still there. And it's only in the last decade where the LEDs come in, but you can see that it doesn't follow the same curve, not at all. And one of the reasons why I want to talk to you about today is why it doesn't follow the same curve. The reason why it doesn't follow the same curve is because we are sitting on the same curve as semiconductors. So actually, in essence, the backbone of technology is pretty much the same. So the same evolution of, I don't know if you remember in the 90s, early 2000s, there were the processors were going mental. They were going from, every 2 years, they were actually doubling. And there was the point where we all used to change computers. We used to get, every 2 years, the computers would get too slow for the operating system, and you go and upgrade the computers. Now, remember, that was 10 years ago. And today, I don't know about you, personally, I have a computer on my desk that is probably 8 years old, and it's still working fine. So we've gone to the point where this race towards energy efficiency or towards efficiency has basically slowed down, and then you need to start looking at other things. And this is kind of where we're getting today with the LED as well. I wanted to show you the fact that I'm not making this up. This is the transistor density evolution curve in time, and the LED efficacy evolution, which has the same backbone to it. This is the same reason, the same physics behind it. It's actually a fairly sophisticated process. So the LEDs are grown on silicon or on different materials, and we've had a lot of changes in the way they're grown, on the substrate that they've grown from. We've gone from LED to gallium nitride. You're probably familiar with some power electronics that's done the same thing. So this technology change has given us a massive boost into the future, and that's what's causing the curve. This is actually, since majority of it's really LED is probably going to be the most dominant technology in the near future, I thought it would be interesting to show you the costs. Quite often people ask us questions going, but when are the LEDs going to become affordable? Look at what's happened. We've been doing the industrial lighting from 2008, back when they were really expensive. And then a lot of these costs have come down significantly, but the demand's gone up. So not only the demand's gone up, the power efficiency's gone up, like a lot of technologies has changed since then. So you will actually find that the products that were made in 2008 are probably not as efficient and not as good in terms of light output as the new products that are manufactured today. Same way the computers that were made in 2000s when this was happening to the computers, the same way these computers were getting outdated very quickly. One of the biggest slowdowns in LEDs, one of the biggest challenges is what's called a droop. Basically, a droop is a drop in efficiency as you ramp up the power. And this is one of the reasons why the LED technology has a limit. And we are approaching this limit. We've actually approached this limit once before. This limit was close to 120 lumens per watt. There was a barrier in late 2010s, 2008. That's where we started approaching the limit of 2010, 2012. We started approaching the first barrier of the first silicon-based technology, or silicon-based substrate. And then that's when the gallium nitride really kicked in, and now we have a different target, and again, a different level, and again, group is a big problem for us. But there are different technologies already bringing on. There's probably 3 or 4 different substrates types that can be switched, and we're going to keep going. So if we wanted to achieve the best energy efficiency, then probably one of the best way of doing it is just switching it off. Like if you really wanted to save energy, sure you can get a more efficient light source, but one of the simplest way of controlling it is lighting control. So, and that's actually, I don't know if any of you built recently, built houses, we're involved in building. A lot of it's actually become almost mandatory now. So you need to have at least some basic control. So you have timer control, where this is a graph from the office I found. At night time you switch it off, during the day you switch it on. It's kind of like a baseline. But then if you segmented the lighting into separate groups, and you had, for example, instead of just coming in and flipping one switch and turning the whole room on, if you had little sectors where different people came in, you could actually cut a little bit off the graph and you could save a little bit of energy. The next thing you can do, you can integrate motion sensors. So for example, if there's no one moving in there, so even though people are supposed to be in there, you can again drop some and save some energy. And the next thing, you can actually integrate together motion sensors and daylight sensors. So when these things just started, they were incredibly expensive. These days, these things are almost 2-in-1. You can get a sensor that's 2-in-1 and it will do this from that. So that is an incredible energy saving tool that is completely inexpensive and is readily available today. So you can see where I'm going with this is that the energy efficiency is now being achieved not just by blunt lumens per watt increase in technology,
but by other means. And that's actually predominantly what's happening right now. So if you actually look, if I could plot an an energy efficiency kind of adoption curve, that curve would not correlate to the curve of energy efficiency development of LED itself, because it's just being pushed by all the other technology. One of the biggest evolutions coming up, actually camera technology is becoming so inexpensive, so cheap, that you can actually now start to use cameras. So when you're going back to something like that, that's a daylight sensor, that basically picks up. There's motion, no motion. When you have cameras, you can actually separate motions in different triangles, you can control so much more. And one of the first evidences that this is already happening is that you probably see them in the car parks near you. This is the same technology. Inexpensive camera is looking whether there is a car, sometimes one bay, sometimes two bays, but the same technology can actually start now being used in sensor technology, and then you can, again, push it a lot higher. This is one of the examples. So for example, if you had a camera control and you detect some people, and then you can literally light up that particular area. So this is in the future, in the very near future, and actually it's already starting today. The lighting is not becoming more efficient and more powerful, it's becoming more intelligent. Because really there's only so much power limits that you can push, and then as you cross to the new boundaries of lighting technology, the cost is there again. So instead of pushing the cost, you start becoming smarter and you kind of manage it like that. So it's really about intelligence. One of the most critical things actually that's pushing our world forward is optics. So you can produce light in a certain way, you can get so many lumens of light, but ultimately if you're sitting really high up and you need to cover a very large area, you need to produce either a lot of lumens, we're talking a lot of lumens, thousands of lumens. You get a really big light if you want to do that, or you can get some really smart optics that can do that. So one of the things I wanted to demonstrate, and I bought this torch for this, now it stays deductible. So if you have a wide beam, this already has a lens. If I took the lens off and I just gathered the raw lumens from the LED, you're probably not going to see the circle. Because this lumen's coming out, but by the time they hit the surface, there's barely any light hits the surface. There's a lot of light scattered around. But if you were to focus it, you can get a very bright spot. So you're familiar with this. This has basically converting lumens into candela, into lux, which is the brightness of the surface. So essentially, optics has a massive role to play in illumination of the future, because you can take the limited number of lumens and you can direct them where you need to go. This is one of the reasons why LEDs, when they started to replace 1,000-watt lamps with 200-watt LED device. So on the efficiency, on the efficacy scale, they were actually very comparable. Not only that, LEDs were almost the same, if not worse. But they were able to do that because instead of wasting 1,000 lumens, 1,000 watt of light everywhere, you could focus it on where you need it, and you can get the light there. So this is early. Now, in the future, we are going to be working more and more with matrix optical technology. So you're kind of talking not just one lens, but an array of lenses, recreating literally the pattern that you need. So you can actually, and you will see this already happening in Audi headlights, so BMW headlights. They actually have an array of individual LEDs with individual lenses, and as the traffic is oncoming, it will drop that particular section. Or, I've kind of skipped here, you can actually follow a person. So this one light source can follow a person. So you could have an average background light level of something like 4 lux or 5 lux, which is enough for you to see and be quite comfortable. But where you're walking, that's where you need 40 lux. So you can actually follow with those segments just by turning on particular segments. And again, this is going from, if you wanted to save energy, switch it off. Because there's only so much the efficiency can take, but if you really switch it off, that's when the real energy savings come. One of the biggest things that we'll need to shift into the future is the shift of our mentality. So we're going to have to really push it. So somebody's going to have to fuel it. Somebody's going to have to say, you know what, we need this. Because right now everyone's kind of going, lighting, Jesus. You know, like we're too busy for this. But lighting is actually quite critical. I do different presentations on this, talk about standards, talk about importance of it. But you do need it. Ultimately, human beings were made to work during the day and sleep at night. So we need to have light levels for safety. There needs to be certain light levels, so we definitely need that. And we're going to have to push it through standards, like I said. For example, in the States, the lighting standards are higher than in Australia.
I mean, we're the same people, but how come their standards are higher than ours? So obviously, there's something something like that will need to be taken into consideration. And as lighting will play a bigger and bigger role in our lives, this will actually fuel more and more of the mentality change. Sorry. This will play a bigger and bigger role in our mentality change. So this is one of the other applications that I was talking about. This is the glare control. So if you wanted to have a lot of light on the surface, one of the best ways to do it is to bring the light source closer to the surface, because then you're wasting less lumens and you're heating more. The problem with that is it's glaring. But if you had an intelligent optic, then you could do that. You could literally cut out the glary part. And you could have that person walking through a really bright field. Sports lighting, well, sports lighting is tough not to do that, but that's one of the reasons why the towers are so high, because they're trying to avoid glare. I'm not saying this needs to be done in sports lighting, because this is going to be a nightmare, light show. But I'm saying this is the kind of concept that can be done with intelligent optics and intelligent sensors. Another thing is we're actually evolving in terms of materials. So one of the hardest things for a lighting manufacturer to achieve was for us to seal things from water getting into them. So that means we have to put rubber gaskets, we have to put metallic casings, they have to be designed in a certain way. And this is always a problem. This is actually where the majority of the cost is. But these days we have technologies that can put the light feeding. Literally, it is a compound that is liquid that we just put on top of LEDs, because they're not running hot. This is the machine that we invested, cost $1 million. But ultimately, we can create a solid brick of light that is completely concealed. There's a little animation of how it gets done, and then you literally just pot it. I do have a sample with a cross section here, so if anyone wants to come and have a look, you can. So one of the biggest challenges in the past was light sources were fragile. You could smash it. This is not the case anymore because it's completely solid. Light sources we used to leak water, not the case anymore because it's completely solid. Light sources need optics. We have optics, whereas before it used to do all these things and you couldn't control the light. So you can see that the evolution is actually going way past the LEDs. We're all thinking, in our day-to-day world, we think that it's the LED that's evolving. It's not. It's everything else evolving together with the LEDs that's pushing us forward. So now you're able to make compact light source, really compact light source that can withstand tremendous vibration, can withstand tremendous impact, does not take on water, can last a long time, and all these things. It meets many of these requirements that we wanted for, but they were not available in the past. However, what can we do with this? So we can actually put it into application that was not possible before. So what we normally do is, instead of just one of the worst things to do, is to innovate for no reason, like just because you're innovating, because you're feeling creative, and you want to make something that you think is going to be good, but then you make it and nobody wants it. So this is what we're trying to avoid, because this is the worst disaster. What we're trying to do is we're trying to collect what application would a product like that be used for. So one of the applications, this is a mining dump truck. So mining dump trucks in today's world, they tend to kind of continue with the evolution that they did, and one of the most natural evolutions is just put more light on it, right? Put more lumens, let's put more light, and then put more light in the front, more light in the back. But what actually happens is this is what the truck looks like. Whereas the truck would look like this. Now, you can actually see the truck. The interesting thing is we're not actually doing it for the driver, we're doing it for the mine management. We're doing it for safety, for the surrounding, because we now have light sources that we didn't have before. This is what it could look like with these trucks today, and this is what it could look like with these trucks in the future. So you can see that the little change can actually make a lot of impact. One of the interesting comments that I usually get at this point is people saying, but the trucks in the future are going to be driverless, so you don't even need the light. You know what, it's a very, very valid point. You don't need the light. However, if the trucks were driverless, there's still people in the pit. If the trucks were driverless, I would not want to be if I can't see that thing. And yes, it is a psychological factor, but hey, we're all human, right? We grew up in the caves. We do have psychological preconditioning. I want lights on the truck if I'm going to be in the pit. And you know, it's not an expensive change to make. So again, without, you can see the big difference. One of the biggest evolutions that's happening now, like I said, it's going to happen in control technology. So control technology is not like we have one process, we have sensors, but now sensors can actually talk to each other. This is one of the reasons why we have Internet of Things or smart homes. This is when devices start to talk to each other. So one of the most common protocols is Z-Wave, Zigbee, Bluetooth, DALI, RDM, DMX, KNX. We have many protocols developing at the same time. So that means that all of these devices can talk in different languages, and each one has a different advantage to the other one. So they could have different distance, they could have different speed, they can have all sorts of stuff. Another thing that's happening, you can actually position track a person through a smart Wi-Fi access point. So commercial smart Wi-Fi access points can actually distribute the signal 360 degrees, but they can pick up which direction the signal is coming from. So you can triangulate between 3 Wi-Fi access points. You can triangulate where people are. So what's the most common thing? Most of us on the mine sites, really hard to find people, right? You know, when you're looking for Bobby, where's Bobby? God knows. You know, and we haven't seen them a whole day. You can actually find Bobby because Bobby's got a mobile phone in his pocket, and you know where he's going to be. Yeah. They might be already doing that because that's just a matter. It's just one of the features of one particular brand of the access points, but that feature is now getting used more and more by management. So when that happens, let's put these things together. If we have a compact light source and you could track people and you could find where they are at any one given stage, you could do something like that. Instead of having poles lighting up, poles are expensive. You have to put up poles, you have to wire them. You can put low voltage potted strip with optics that lights up precisely the floor in front of you, and you could have 4 lux on the ground until somebody walks into it, and then the light literally travels with you. Just enough in front of you so you can see, enough behind you so you can see, but you don't need to light up the whole thing. This is the application. So we're starting to innovate towards the application because we know that's where the demand is. One of the biggest demands is this is an excavator digging dirt and dumping it into a truck. That's called a circuit. I'm sure most of you are aware of this. So there's usually many trucks. One excavator costs $10 million. There's 5 or 10 trucks that cost $5 million each, all working in the circuit. They're timing it to seconds. So any particular motion that can be minimized, so they can load the truck in 2 passes, they can load the truck in 3 passes, that could save them millions. So one of the biggest wastes is when the truck digs, and he picks up the bucket, the truck doesn't know where to line up. So the excavator has to stand there and hold the bucket going here. And the truck backs in towards the bucket, because if he backs in too far or too close, then it's going to affect their passes. That is delay. So what you could do is you could have a narrow beam projected onto the floor, and you're showing literally where to line up as the excavator is still digging. That speeds up the whole circuit a lot faster. We're talking, you shave 10 seconds here, 10 seconds there, 10 seconds there, and you end up with millions of dollars of savings. The new technology that's coming on the horizon, that's actually quite big, is a white laser. So white laser has been discovered fairly recently. Well, not discovered, it's been synthesized very recently, but it's actually got quite a lot of adoption. So it's literally helping us do what we really struggle to do, is to make a very narrow beam. Because with lamps, so in order to make a very narrow beam, actually one of the earlier slides that I had big reflectors, you need to have a really big reflector. The reflector has to be a number of times bigger than the light source. So one of the reasons why optics developed so fast, because the lamps used to be big, and the optics would have to be big. When the light source is tiny, the optics can be tiny, and then you can have many of them, and you can have different shapes, you can have different distribution patterns, you can have all these things that were never possible before. But laser, naturally, is a very narrow beam, as narrow as it could not possibly be made. So if we had a white laser, what would be the application? So that's we were thinking, one of the big applications for this is the pits usually lit up, and the idea is to light up as much as you can, but it's not physically practical. So if usually they bring in massive lighting towers, and kilowatts of light, which is kind of leaning over the edge of the tower and just go, and they hope for the best. But usually that's not enough. But what we're thinking, that if the white laser became commercially available, you could have a laser shining into a reflective balloon. So you can essentially have an aerostatic balloon just pinned down, anchored to the ground. And because you have the tracking technology, basically it's a very inexpensive tracking technology, you can actually line it up and shoot it and light up the bin. There's a massive evolution of power sources. So you've got a whole myriad of batteries coming up, that's going to affect us. So I'm going to speed up. You could have a portable headlamp that can project light in all directions, not just forward, and you can actually regulate it depending on which way you're going, what's around you. You can actually control all that. There's new technologies of OLED. There's many technologies developing. Some of them will take off. Some of them are going to be too weird and not commercially. This is already commercially available. Quantum dots are actually improving phosphor, improving color rendering of LEDs. There's bioluminescence, so there's people working on making the plants glow and the trees replacing street lights. That'll be cool. So if they can merge the genetics of the jellyfish, glowing sea creatures with living plants, then theoretically we could actually have glowing plants. It's pretty cool. There's going to be a massive boost in solar, so there's already been a boost in solar that's going to keep evolving. Actually, solar technology is the same backbone as LED. It's actually a flip side of the same technology. So as we changing substrates and evolving, they're evolving the same way. One of the interesting methodologies that we use for innovation is that innovation is not in a straightforward line. Usually it goes in jumps. You really have to think outside of the square. There's no point just keep evolving and making it brighter. You really need to think outside of the square. So, definition of innovation, the process of translating an idea or invention into a good or service that creates value for stakeholders, in that case, mining stakeholders. This is a very vague statement. Who are mining stakeholders? Is it management? Is it, who are mining stakeholders? My impression of mining stakeholders. What we really need to understand is who are the people that it affects. It actually affects all of us. It affects people who are present on the mine site at night, because ultimately we are the ones who need the light. So what I wanted to do this presentation for is actually to call on you. As you can see, there's many different technologies and there's many different wonderful things that are coming up and many things that can be done, but we don't want to do it just for the sake of doing it. What we want to do is we want to hear from people, the stakeholders in the field, to say this is the problem. And then we could innovate towards making a solution to the problem. Instead of us just innovating and shooting lasers at the balloons, we could actually make specific solutions for specific problems. So I think all of us joining together and doing it together with a good aim in mind, we can actually push the technology forward. And the tools are there, but it's this push that is needed, and that's what we're trying to get out today. That's all to me. Thank you.